So let's start Ciros Studio and MES4. Ciros Studio and MES4. MES means Manufacturing Execution System. Using these two, we can simulate a smart factory. So using Ciros and MES4, we can simulate smart factory. As in this picture, we can see these are the different CP factory modules. As you can see, a mobile robot here, and we can see conveyor belt, right? Then production stations, right? Different stations, right? Okay, and this MES will control the entire system. So virtually, we can control the entire system using Ciros and MES4. So the main objective of this these two application was to simulate the real factory on your computer. So in this tutorial, using the software version, let's see. Yeah. So in this, the software using is 6.4.4 and CPLab Factory Model Library 4.15. Then Fleet Manager, MES4 4.1.2.1.8. Okay. So combining all these four applications, we can simulate the factory. So once we will install these applications, these are the folders we will get. For example, Ciros, Fleet Manager, License Manager, MES4, Factory Models, Tutorials, Examples, etc. So these are the folders we will get after the installation. Then let's start the introduction to Ciros. So what is Ciros? Ciros means Ciros means CIROS. So Ciros means this is robot. ROS means RO means robot. Robot S means simulation. CI means computer integrated. So completely Ciros means computer integrated robot simulation. RO means robot. Robot S means simulation, and CI means computer integrated. Computer integrated robot simulation. So that means the robots, the factories, okay, we can see on the computer. So we can operate the robot, we can run the factory, okay. Without an actual factory, we can run the factory using this Ciros application. So the main advantage of this is real-time 3D simulation. So real-time 3D simulation. Real-time 3D simulation means we can see the live operation of the machines. Big model library. So the main advantage is that this is having a large model library, having Festo factory modules, Robotino, Mitsubishi robot, conveyors, sensors, all are available here. So large model library is available. Then another one is that CAD import. That means from Fusion 360, SolidWorks, Inventor, we can import step files. Then another one is that several interfaces. That means this software we can connect with MES for Fleet Manager. We can connect with MES for Fleet Manager, MATLAB, uh, Python, VR glasses, Mitsubishi robots, etc. Then user interaction during the simulation. That means during the simulation, for example, we can turn on the sensor, turn off the sensor, we can move the robot, or we can change the part, etc. So user interaction is available during the simulation. We can check the collision analysis, uh, whether machine will collide, or will the robot is moving, will the robot uh, will collide with another robot, or another structure, right? We can check that also. Then fault injection, right? So fault injection or simulation means machine failure, sensor failure, motor failure, emergency stop, everything we can check in the simulation. Then coming to the next is the PLC and robot programming. We can test the PLC, and also we can test the robot program. Coming to the overview of this application, studio versus education, we have two options. One is Ciros Studio, and the second one is Ciros Education. So Ciros Studio means this will be the full version, right, including all the features. Here we can design new models from scratch, designing and saving models from scratch, and we can save it. We can download robot programs. Okay, we can download or upload programs. Then we can upload the program into the Mitsubishi robot controller. Okay, so this is the best option for teaching. Fits perfect for preparation of teaching scenarios to be analyzed by students. Then another option is called Ciros Education. Okay, this is a student version actually. Okay, here the advantage is that already existing models, we can analyze and modify it. Okay, and we can change it. We can change some small changes, right? But we cannot save this. Okay, and there is no robot controller interface. So in this Ciros Studio, we can design and saving models from scratch, but that is not available in Ciros Education. Then coming to the language packs. So language packs means in Ciros having different language packs, for example, English, German, French, Spanish. During the installation time, we can select the language. After that, we cannot, once we select it, after that, you cannot change it. Unfortunately, the desired language has to be set during the installation. There is no option to change the language during the runtime. So on a computer, we can install Ciros 6.2, 6.3, 6.4. Okay, we can install. Installation of different Ciros releases and language packs on a single PC possible. Okay, different Ciros releases we can install on a same computer is also possible. And coming to the hardware requirements, so in order to operate the Ciros, we need a computer with the operating system Windows 10 and processor Intel i5 or i7 is required. At least 8 GB RAM is required. So yeah, Windows 10 operating system Windows 10 and in Intel i5 or i7, right? And 8 GB RAM is required. At least 8 GB RAM. SSD 4 GB memory required. Graphics card with OpenGL 4.5 and 4 GB dedicated memory. And the license will be either through USB dongle, USB port for USB dongle, or network access. So the their suggestion was uh, two screens are highly recommended. Okay, so Ciros will be in one monitor. Okay, and MES4 will be on another monitor. Also, it is also possible to run Ciros on MES4 on different PCs. So Ciros and MES4 on different PCs. So we can install Ciros on one computer and MES4 on another computer. And also we can communicate this through network. So that means Ciros simulation in one PC and yeah, see this. So Ciros simulation in one PC and MES4 in another PC. But we can connect this using the network. And coming to the installation, DVD or open the installation folder, and after that press the start exe button and then run it. After that select the Ciros applications. So installation options we have, as I have already mentioned, we have two options. One is Ciros Education and another one is Ciros Studio. Ciros Education means this is the student version, and Ciros Studio means this is the professional version. So Ciros Supervision. So we have Ciros Education and Ciros Studio, right? So this is for students and this is professional version. Ciros Supervision means this is the factory monitoring software based on MES. So what we discussed about Zeros. Zeros means computer integrated robot simulation application. This is a 3D factory robot simulation software. MES4 is a software used to control the factory production. If we can combine these two, utilizing the capacity of these two applications, we can simulate the Industry 4.0 smart factory. We have two options, Ciros Studio and Education. Ciros Studio is the full version. Education version is having some limitations. Education version means we can use the existing models only, but in Studio version, we can create models from scratch. Windows 10 operating system in the i5 or i7, 8 GB RAM, NVIDIA graphics suggested. We can use Zeros and MES4 on same PC, or we can use in two different PCs. During the installation time, we have to select either Ciros Studio or Ciros Education. Then coming to the next slide, Python installation. Okay, so we need Ciros plus we need to install Python or Python. So Python 3.6. Okay, we have to install Python 3.6 or greater version has to be installed. So the complete CP lab or CP factory model library is working on this Python. If there is no Python, factory models will not work. Workpiece parts will not move properly. Automation logic will not work properly. So during the Ciros installation window, select the Python option and install that one also. So Python installation is very important. Okay. So during the installation time, tick this option, add Python 3.7 to path. So path means where we installed this Python. We are telling to the Windows that where we installed this Python. That is what is called a path. If we didn't tick this, Ciros will not be able to find Python. So at that time, error will happen. So this checkbox is very important. Then after that, installation of MES4. Now we are going to install MES4. This is very simple. During the installation, in the installation menu, select MES4, click and next, finish. Then exercise. Now here, these are the softwares we need to install: Ciros, Python, and MES4. Now there is no need to install the Fleet Manager. We will install it later. Python warning. So after the installation, open the Ciros. Okay. When you open the okay let me open the Ciros Studio 6.46 open. So when you open the Ciros, uh, check any warnings will be there. Okay, if there is warning, it is not correct. So for example, Ciros is not able to find the Python executables. That means Ciros will not be able to find the Python. That the problem was we didn't add the path correctly. Okay, or we didn't install Python, or we installed a wrong version. Okay, again, install Python and select the tick path. Okay, so next is called a code meter, accessing code meter. So code meter means the software the software used to manage the license is what is called a code meter. So this will read the USB dongle license. On the system tray, we have a code meter icon. If you open the code meter, we can see that USB dongle is connected or not. So once we open the code meter, just right click it. Then select web admin. Or from the code meter window, we can select the, we can open it. So when you open this web admin here, we can see the license list available in the USB dongle. For example, Ciros Studio, right? Ciros Education, MES4, etc. So we can check whether this is available or not. So these are the list of licenses on the attached USB dongle. Okay, suppose the license is in one computer. Okay, suppose the license is in one computer. Okay, how we can use the license in another computer? Enable the server option. Enable this server option. So go to configuration, server, network server, enable, enable, and then after that click apply. So if you do like this, then this computer license will become server license. After that, open the CodeMeter web admin in another computer. Then after that, okay, go to next page. Then go to configuration. After that, server search list. Then after that, add new server. Then the computer name or the IP address of the computer having the license, enter it so that we can share the license. So we can use it in two different computers. So connecting to CodeMeter web admin server. So again, open this web admin. Then after that, go to configuration. Then server search list. And after that, add server, new server. Here we have to enter the IP address of the computer having the license. For example, 172.21.0.99. After that, click the add button. Then after that, click apply. This apply is very important. Otherwise, this new configuration, we have to save the new configuration, right? So to save the new configuration, click this apply button. Then connecting to a CodeMeter web admin server. So here this will search the available network license server, okay, on the CodeMeter network. What are the available license server available in this CodeMeter network? For example, localhost 172.21.0.99 and also other server name. So select the server and press apply so that we can use that particular license. Then Ciros license manager. So license borrow. So normally we will get license from the license server, right? But sometimes we need to take the laptop outside. There is no network, right? So offline we have to do the job, right? So at that time we have to copy the license to the computer. This is what is called a borrow license. So to borrow the license, we have to run the license manager.exe. Okay, we should run this in the client PC, not on the server. And the password will be didactic2017. When you open the license manager, so this is showing the license manager. So it will shows the list of the license where we can borrow. For example, Ciros Studio MES for industry version. So every license, what will be the type? Then total, borrowed, free, everything will be available. All the details will be available. Through this, we can identify which license we can borrow. And here we can enter the borrow time. So for example, in seconds, 600 seconds, or some days. So what will happen after this borrow time? The license will automatically expire. Once we will successfully borrow the license, we will get a message that license successfully borrowed. After that, we can use the license offline. After borrow the license, go to CodeMeter web admin, where we can see the license name, valid, quantity, borrowed status, everything we can check. So finally, so we have the license, right? So license through this CodeMeter, right? So we have a USB dongle. So the license is coming from, sorry, dongle. So the license is coming from this USB dongle. So this USB dongle to the server PC, right? Okay. Then through the network, we can connect to the client PC. So borrow license means we have our server PC, right? So we have our server PC, we will borrow. So we will borrow. Borrow means offline. We can use this license offline. So after that particular time, the license will expire. Okay, coming to the application scenarios. We can use this Ciros computer integrated robot simulation. This application we can use for different applications. First one is So first one is data generator for data analytics. That means we can generate data. That means sensor data we can generate. AI, machine learning, data analytics. We can generate data. For example, we can collect different data. In the case of robot, how much time the robot, took. So that data we can collect it. Then another one is we can use this for large classrooms. Same simulation you can teach to multiple students. This is very much useful for CP factory training. And the next one is the CAD import. CAD import means Fusion 360, SolidWorks. From those softwares, we can import CAD models. Then virtual commissioning. Before commissioning the actual machine, we can simulate the complete machine in this software. And also we can run the PLC program using this simulation. Then process optimization. Process optimization means we can identify which layout is quickly working, and also we can identify bottlenecks. Then PLC programming. We can connect the Siemens PLC program directly into the Ciros and we can test it. No need to connect it to the real system. Virtual reality. Using factory VR, we can walk through the entire factory. Then video export. This simulation video we can export to a video. And fault injection, sensor failure, motor failure, robot failure. We can create this. How a sensor will fail, what will happen. Okay, so we can inject this failure, fault injection, and then we can take the response. These are the different application scenarios related to Ciros. Then process optimization. Here it is showing two different layouts, right? So the process will be front cover. We have front cover, then measuring, then back cover, pressing, heating, delivering, right? So now we are talking about process optimization, right? So process optimization means so we have two different layouts. So which layout is taking robot less time, more throughput, right? So that layout is what is called. So that layout is what is called a good layout, right? So less time and more throughput. Okay, that is what is called a good layout. So now you have two different layouts, right? So using Ciros, you have two layouts, layout A and layout B, and compare these two layouts and which one is good. You can identify which layout is good. Then next one is called a PLC programming. We can connect the, for example, we can connect the Siemens PLC to the Ciros. So TIA portal, then PLC program, then zeros, and finally simulation. Or so the flow will be TIA portal, PLC program, zeros, and simulation, right? Or using the real PLC, zeros, and virtual factory. This is what is called virtual commission. Okay. So zeros is equal to digital twin. This is a question. Okay, what is your answer? See, digital twin. So what is the definition of digital twin? So see, I will mark here. Okay, so one is zeros, and another one is digital twin, right? So, Ciros, it will behave like exactly like a physical system, right? Having PLC communication, MES communication, robot communication. Timing is realistic, but we have real-time sensor. We have real-time sensor data, right? So the real-time sensor data is not using in a live mode. So Ciros is a high fidelity simulation tool. In majority of the situation, we can use this as like a digital twin. If we can connect the Robotino project with Robotino MES Fleet Manager PLC, it will be like a similar system connected with digital twin. So here, so Bolton is a digital twin is a dynamic. So this is dynamic, right? Virtual representation of a physical object or system using real-time data and interaction between them. As per this, Ceros is not a digital twin. So Soderbergh, using a digital copy of the physical system to perform real-time optimizations. A digital twin is a real-time replica of physical device. So digital twin means we have our physical system, we have our virtual system, and there will be a to and fro communication. Okay, for example, here the temperature is 25. Here also the temperature is 25. Here the pressure is say 10. Here also the pressure will be 10. It will be exactly same. So that is what is the definition of digital twin. Okay. Then coming to the window layout. Okay, now we are going to use the software. Coming to the window layout. Coming to the window layout. Okay, when you open this software, we have a model explorer, right? Okay. Model explorer means here you can see the all the objects available in the factory. For example, robot, sensors, PLC, conveyor, motor, cylinder, etc. Then we have properties window. So properties window means what will be the property of the object. For example, what will be the speed, position, name, color, parameter. So all the properties we can change here. Then we have model libraries. Here we can add new components. For example, robot, conveyor, sensor, motor, cylinder, etc. Then we have a window called a view window where we will see the 3D factory simulation. And we have a real-time indicator simulation 1.0. Okay, real time. If it is simulation 1.0, it will be real time. Unless that means computer is slow. Then we have, yeah, next page. Yeah, next we have another option called help menu. So in the help menu, we have example models, tutorials, documentation. So if you are going to learn this new concept, it will be very much useful. Okay, so now I am going to open the software. Okay, let's see the window layout. Yeah. So go to help. So go to the help menu. Here we have the different models of Ciros Studio, right? Then models of Ciros Education. So next we are going to discuss the keyboard shortcuts, right? So this is plus minus represents, this is used to zoom in, zoom out, right? Okay. Shift plus left mouse, view move, but it is not moving. Okay. So control plus right mouse. So control plus right mouse, rotate. Okay, but it is not working. Okay. So no problem. So plus or minus. So plus means zoom. Plus or minus. We can use this using zoom in, zoom out. So V represents the front view, right? So V represents front view, right? Here, yeah, this one, the front views. So V represents front view, and H represents rear view, and A means top view, right? So V is front view, H means rear view, and A means top view, R means right side view, right? L means left side view, and Shift O means full screen. Okay. Then F5 is for start simulation. Control Control F5. Control F5 is for reset simulation. And Control E. Control E means a view mode. Okay. Then Control plus. Control T. Control T show model explorer. Control F9. Control F9 to compile PLC program. Control Shift M show the model libraries. So Control T will shows the model explorer, and Control Shift M will give you the model libraries. So in the view mode, we can see the scene, right? And also we can move the camera. We can rotate, zoom. Cursor will be a normal arrow. In the edit mode, we can move the object, rotate, delete, right? So we have view mode, right? So in the edit mode, we can move the object, or we can rotate the object, and also we can delete it, and also we can change the position. Then creating Ciros models. So Xerox model means having .modx file. Okay, in a file, so in a project we have .modx, then .ini, then CF and textures. So what is the use of this one by one? Then Ciros modx. This is the main model file. Ciros.modx is the main model file. This one. This is the main file. Okay, this is the main file. Okay. Then .ini. .ini means this is the project configuration. Then we have CF folder. So in this this is CF. In this CF folder, we have our PLC programs, controller files, internal configuration, etc. And we have textures. So textures means the textures related to the 3D model. So do not copy the only this modx file. Okay, when you copy, you have to copy the complete file. You have to copy the complete project folder. Okay, so now we are going to create a new zeros model. Okay, so close. Okay, go to file. Okay, go to file, new. When you click go to file, new, you have an option called a model assistant. Okay, click this model assistant. Okay, first of all, here we have to give a new name. So for example, so robot one. I'm going to. This is my uh, okay. I will give study one. Study one. Okay, and then here uh, create a subfolder with the same name. Right now, I have created D folder test study one. So tick this box, create a subfolder with the same name as the model. Okay, so next after this, okay, go back. Yeah, okay, select next. Now you are going to select the model type. Okay, so you have two options, model with robot and MD model. Model with robot means you can select manufacturer. You can select, for example, Mitsubishi. Okay, okay. So if you are going to use CP factory, do not select this robot model. You have to select the MT model. Okay, so click this MT model. Okay, next, name of the creator. Next. Okay, so this is the starting stage. Let's go to the, yeah, where I saved this PC, option D, test study one. Okay, if you open study one, here you can see modex, right? So we have two files, right? modex.ini. So this is actually the folder. Now we have two files, modex and .ini, right? Okay, and this is our main file. Study one modex is the main file. Okay, so now I have opened a new uh, file, right? Study one, right? So this is our workspace actually. Okay, next we are going to add new libraries to Ciros. Okay, when you install Ciros, CP factory library will not come automatically. We have to add manually. Okay, so go to this page. Not this page. Go to this option. Then it's not working. Yeah, go to modeling. Okay, open the modeling. Then after that, model libraries, and the shortcut key will be Control Shift M. Control Shift M. Control. Sorry. Control Shift. Control Shift M. Yeah. Model libraries. Or we can use from here modeling, model libraries. Both are same. Control Shift Control Control Shift M. Control Shift M, or we can modeling, go to modeling, model libraries. Right? Hmm. See, if you open now you opened a project, right? It is not working. Yeah. Copy. Now you, shit, what is this? Now you opened a project, right? So when you opened a project, you can see this option, modeling option. Here there is no project you opened, right? So there is no modeling option. You have only three options: file, window, and file. So if you opened a file where you can see this option, modeling option. Okay, then after that, we can select from the modeling, select this option, model libraries, or the shortcut key will be Control Shift M. So once again, go to modeling, model libraries, or Control Shift M, Control Shift M, Control Shift M. Okay, so next you are going to add folder. So right click and select add folder to list. Add folder to add folder to list. Okay, so right click, this one, add folder to list. So here you have to select, here we have to select the folder where CP factory library stored. CP factory library stored. So the next exercise will be add the CP lab or factory model library to the Ciros. Okay, so next is our virtual commissioning. So virtual commissioning means before manufacturing actual machine, we can we can test PLC program, robot motion, sensors, conveys, pneumatics, everything we can test. This is what is called a virtual commissioning. That means before operating the real factory, we can simulate everything. PLC logic, sensors, MES communication, fleet manager, everything. Then, so this Ciros library is divided into four main sections. Okay, so the Ciros library is divided into four sections. One is CP application, and the second one is, okay, I will mark here. One is CP application, and the second one is CP factory. So CP application means it will shows the application modules. CP factory means it will shows the factory components, and CP lab is for educational modules, and we have CP mobile robots, robotino components. Every module, if you click, you will get a small picture with a small description and a name. See, as we have discussed application module means, see, for example, this is our application module, right? So for example, camera inspection, heating tunnel, drilling module, pick by light, label printer, front magazine, back magazine, manual workstation, measuring station, press station, output station, turning module, etc. Then we have our factory components. So factory components means, the conveyor branch, conveyor bypass, carrier, 180-degree turn, CNC milling station, conveyor belt, robot assembly station, sink to remove carriers, pallets, workpieces, source to generate carriers, pallets, workpieces, highway warehouse, branch, etc. Then CP lab related components such as conveyor branch, carriers including pallets, conveyor belt, passive 90-degree deflection, warehouse, sink to remove carriers, generate workpiece, source to remove carriers, pallets, and workpieces. And then Robotino related components having two different modules, CPMRC, this is the carrier robot, and CPMR dock. Okay, if the robot will reach here, it will dock and undock. So these are the two modules available related to the robot. Then coming to the part numbers, every workpiece is having a specific number. So for example, 109 or 110, 111, 210, 310, 410, etc. So every part is having a part number. This is to identify the part. For example, 109. So for example, 109. So 109 means gray color front cover. So 109 means it will be gray color front cover. Then for example, 410. 410 means it is blue front cover, right? So blue from so right. Then 111. What is 111? So like that, every workpiece is having a specific number. So in the simulation, uh, MES will use this number. In the simulation, MES will use this number to identify the workpieces. So for example, 412, right? Okay, so for example, 412, right? So this is, blue cover PCB with the front fuse, right? Then 513, red cover PCB rear fuse, 1214, black cover front fuse, rear fuse, etc. And part 109, gray raw material color cover. Then, yeah, this is showing, right? So 412. So 412 means blue color. So blue color with PCB with the front fuse, right? And 513 means red color PCB with the only rear fuse. 1214 means black with both fuses back cover. Then 109 means gray color raw material front cover, like that. So every workpiece is having a specific number. Then we have carrier, right? In Ciros, we have two types of carrier. One is carrier without pallet and carriers including pallet. Without pallet means we can directly place the workpiece onto the carrier. With pallet means on the top carrier we have pallet. So we will place the workpiece on the top of the pallet. So if a factory is having high bay warehouses, we will use carrier without pallet. But normal conveyor system, we will use this one, carrier with the pallet. So the thumb rule will be one carrier per conveyor belt. This is the normal thumb rule. Okay, next we are going to the default procedure for setting up Ciros models. Okay, so the default procedure will be, so when you are going to uh, prepare Ciros model, the default procedure will be select the top view first. Okay, and after that open the model libraries. Okay, then whatever models you required, okay, just drag and drop. For example, unit conveyor, magazine, press station, robot, just drag and drop. Snap passive deflection again. Then after that, configure it. Source, okay, source, sync, then PLC, background, floor, shadow, then MES ID, etc. Then standard views. So we have different views such as, again, go to view where you can click view, go to standard view. How we can change the camera view, such as default view, we have default view, then front view, rear view, top view, bottom view, left side view, right side view, etc. Also, we have rotate, move, zoom, orthographic view, also, etc. Okay, so if you, based on your requirement, you can select uh, the view. For example, default view. This is the, if you open the zeros, you will see this view default setting. If you want to see the front side, you can select the front view. If you want to see the sensors, motors, wiring, etc., select the rear view behind. Then to see the left, click the left side view, and click right side view to see the right view, and the bottom view to see the bottom parts, top view. So this is the main view. During the factory layout, you are going to use this top view. So this top view is very important. Okay, as per the first off, when you are going to prepare the Ciros model, use the top view because all the laboratory components will be based on the z-axis. Okay, so this is very important. This one I will rotate here, top view. This one. So when you are going to prepare the zeros model, select the top view. Then next is the snapping into place. This is one of the main specialty of zeros. That means, yeah, snapping into place. So this means, for example, if you drag a module, for example, this is one application module. Okay, so if you drag this into this application module into the basic module, Soros will automatically adjust the position, orientation, height, everything. So there is no manual alignment. There is no manual alignment required. So this is what is called a snapping into place. So for example, if you have a magazine, right? So this application module connected to this, so Soros will automatically adjust everything. Okay, now you are going to do one practical exercise. Okay, first of all, open a Ciros model, select empty model. You have to add modules from library. Add different modules from library. Do not start the simulation. Okay, First, first you have to configure the CP system. Okay, so like this, here you can see, yeah. So we have branch, right? Then we have back cover magazine. Okay, as you have told, back cover, front cover, right? Then we have a drilling station, right? Then we have a manual working place. We have a measuring station. We have a muscle press, then output station and a warehouse. Okay, so you have to recreate this. You have to recreate this. This is your exercise in Ciros. ചുമ്മാ ഈ താണ്ടി ഇത് ഞാൻ എന്തിനത് ക്ലോസ് ചെയ്ത്. Okay, so let's continue. Next is section CP system. So here we can configure different settings, such as, for example, MES ID. Okay, wait. Yeah. So we can configure in the properties, we can configure MES ID. This is to identify the component. Okay, I have already mentioned that every workpiece there is a number, right? So there is an ID, right? Then we have a traffic jam. If traffic jam control, that means if there is a block in the conveyor, it will control it. Then energy saving, that means if there is no need, conveyor will stop. Branch behavior. Okay, how to how to operate the branch properly. Yeah. So this MES ID is very important because default mode MES4 will not use. Ciros standalone simulation. If MES ID is greater than 0, then there will be a communication with the MES4. If the MES ID of a component is greater than 0 and MES4 is not working properly, then we will get a simulation error. So for standalone MES ID equal to 0 and MES integration, it should be greater than 0. Then coming to the MES ID numbering rule. Rule number 1, every component is having a different ID. For example, warehouse number 1, magazine number 2, drill number 3, measuring number 4, output number 5. So the number will be greater than 0. Zeros as well as MES4, you should use the same ID. If you are using different ID, communication will not happen properly. Okay, so CPAM IPIC example. Okay, next we will see some different examples. Okay, this is the properties of a pick by light station parameter. Here you can configure different parameters such as working time. So for example, how much time an operator will take to complete one work. For example, 5 seconds, 10 seconds, 15 seconds. Then part number. So which number the operator should pick? Is it 109, 412, or 513? Okay, this is another one, magazine, right? So this is the CP settings of magazine, right? Okay, so we have automatic mode and a manual override. If automatic mode is enabled, when we start the simulation, magazine will fill workpieces automatically. Even the workpiece will finished, it will autofill. If it is if it will be disabled, you have to add the workpiece manually. Then manual override. If you enable this manual override, you can select the color of each cover. For example, black, gray, blue, red, etc. So the digital twin experiments, we can test different covers using this. Then CPAM manual. So manual means related with the human operator, right? So the working time. So for example, how much time the operator will take to finish the job? 5 seconds, 10 seconds, 20 seconds. Target number. How many workpieces the operator should make? Percentage faulty fuses, 10 percentage. That means out of the 100 part, 10 numbers will be faulty. Percentage rotated workpieces. Out of the 100 workpieces, 15 will be upside down. Then CPAM measure. This is what is called a measurement station. Measurement variation. So sensor will add the random error. For example, actual value 20 millimeter, measurement variation plus or minus 0.30 mm. So reading 19.82, 20.11, 20.26, 19.95 like this. This will be showing the real sensor noise simulation. Then CPAM out. This is output station. This is the settings related to the output ramp. If the automatic mode is enabled, if the output ramp is full, Ciros will automatically remove it. If it is disabled, traffic jam will occur, so conveyor will becomes block. Then CPAM turning station. That means rotating the workpiece. Before starting the simulation, you have to select which part you need to rotate, entire workpiece or front cover or full workpiece. Then CP branch, CPL branch conveyor settings. How much percentage should go to the right branch? For example, 50 percentage. Right 50 percentage straight. 100 percentage right, 0 percentage straight. And CPFRASS, this is robot assembly station. That means percentage faulty fuses. For example, 10 percentage. Say for example, if this station assembled 100 fuse, 10 will be faulty. This will highlight in red color. This is used for quality control testing. Then CPF ASRS 32. That means warehouse part number. If we are not doing the simulation without MES, this will show which part we need to store. Using the MES4 mode, MES will give the part number. So manual button will not be there. In the standalone mode, we can use the manual button. Then CPF sync, CPL sync. CPF, this means sync station means where the simulation will stop. So this means in the automatic mode, if this is enabled, when it will reach the sync area, everything will be deleted, carrier, pallet, workpiece. If it is disabled, workpiece will be there. Then CPF source, CPL source. This is the station where simulation will start. If we enable from here, workpiece will automatically generated. If you press, if it is disabled, if automatic mode is disabled, if you press the green button, then only new part will come. So part number, which part, which product, part 100, 120, 210, etc. If carrier ID is using, if there is no, if the system is not having RFID, carrier ID is using. Percentage faulty fuses. For example, 5 percentage means out of the 100 workpieces, 5 numbers will be faulty. Percentage rotated workpiece. Out of 20 percentage, 100 workpiece will be, out of the 100 workpiece, 20 will be upside down. Then CPMRC robot, this is the identification of robot, RFM ID, right? Fleet Manager ID. FM means Fleet Manager ID. This is the unique ID. For example, robot, 1, RFM ID 1, robot, 2, RFM ID 2, robot, 3, RFM ID 3, etc. So every robot, is having different IDs. So how to communicate with the fleet manager? We need this ID. Using this ID, this fleet manager is communicating. Suppose you have 3 robotinos having IDs 1, 2, 3. So if I say robotino 2 move to the docking station, if you send this command, then ID 2 robotino will take this command and it will move to that particular station. Do not give same ID. Suppose you have 2 robotinos, 1 and 2. If you give ID 1, okay, so the fleet manager will not be able to understand the which robot I need to communicate. So this will create communication error, collision, or wrong robot movement will happen. Suppose in if you are using only one robot, you can use RFMID 1. Then CPMR dock. This is the docking station configuration. So robot will reach here and it will exchange the workpiece with the conveyor. Say for example, every docking station having a unique number. For example, dock 1. So dock 1, station ID 1, dock 2, station ID 2, dock 3, station ID 3. So using the fleet manager, using this number, we can dock the robot properly. Then number of conveyor belts available for docking. Now the robot will be able to share his box to the conveyor belt, right? So we have to tell how many conveyor belts are there. For example, number 2. That means in one belt the robot can go and in the other and the other belt from the station. So carrier robot will be using 2 conveyor belt. So how this docking is working? So docking means robot will reaches the workpiece. It will properly aligned with the docking station. Fleet manager will check the station ID. Robot will dock properly. Conveyor belt will working properly, and then transfer the workpiece. Once the transfer is completed, the robot will go to the next station. Okay, so let's continue. Now we are going to change some properties of different components, right? So this is the property tab where we can change the properties. So for example, different components such as magazine back, manual out, branch, etc. Right? And after that, save your model and start the simulation. You have to check whether your model is working as expected. Does your model behave as expected? Let's see one model. Next is code sequence trace. See, code sequence trace means this is the program, okay? This is the program, okay? So when the PLC is executing each and every line of the program, it will shown on the screen code. That is what is called a code sequence trace. So this is for debugging actually. We can debug the PLC using this feature. But the problem was simulation will be very slow. Different IRL program windows will open. So because of that, like this, you will get more number of windows. So during the simulation, turn off this code sequence trace. Okay, how you can disable this? Go to programming and then project management. Go to programming, click project management, right? And there you will see the controllers. Yeah, click the controller. Yeah, go to controller and turn off this option, code sequence trace. If you uncheck this, your simulation speed will increase, and also uh, otherwise what will happen during the simulation, this type of extra windows will open. Then coming to the next, floor and background. Okay, so go to settings, and then we have an option called model options, and then from the model option select the display. So go to settings, there is an option called model options. Click this model option where there is a display option. Okay, here in the display you can change the background, right? Change the coordinate system, elements, floor, right? Then floor position, handling, kinematics, object captions, about workspace, selection, sensors, stereo, TCP, transport, etc. Next is disabling shadow simulation. Okay, so shadow, if you use shadow, what will happen? A CPU or GPU usage will be more, right? So we have to disable the shadow simulation. So if this is activated, what will happen? Simulation will become slow. Normally, if the computer is old, it will become slow. So you have to deactivate this shadow simulation. If you deactivate this shadow simulation, your simulation will become faster and the FPS also will increase. Then coming to, yeah, disabling shadow simulation is mentioned here. Next is screen space ambient occlusion, SSAO. See, SSAO means screen space ambient occlusion. Okay. Uh, this means this will, during the simulation time, this will show the shadow, natural shadow, uh, corners like small areas. This is a graphic feature. So if you see this feature, if you see this natural shadow, you will get a realistic feel, right? Okay. But the problem will be, again, it will affect the simulation. Okay. Again, you have to deactivate this so that your performance will increase, as well as your simulation will become more smoother. Then how you can turn off this SSAO, screen space ambient occlusion. Again, go to model, then there is an option called lighting. Then we have an option called ambient light. Okay, so click ambient light, go to properties, and there is an option called shadow SSAO. Okay, here you can see this enable button is activated. Okay, you have to remove it first. Okay, let's see this. Okay, where you go to model, right? Yeah, go to model, and there is an option called lighting, and there is an option called lighting, ambient light, and here ambient light. Here you can see shadow SSAO. Now this is enabled, right? So you can turn off this. Again, if you do this, your simulation speed will increase. Next is shadow light source 1. So this light source 1 is producing the shadow. We have light source 1. So this light source 1 is producing the shadow. Again, the same procedure, go to model, lighting, light source, properties, click the properties, and also you can disable the shadow. See, like this, you disable the shadow. Then application options. So for example, if you are going to create new models, so you need shadow off for all the new models you are going to create. So the option will be file. Then after that, go to application options, then click display, and then you have to deactivate shadows and deactivate SSA, enable this. And after this, when you are going to create new models, it will run very fastly. Okay, I will show you. Go to file, application options, and after this, go to display. Okay, go to display, and where is the display? Yeah, here. This deactivate shadows, deactivate SSIO. You can deactivate this. Okay, so these are very important because it will increase your simulation speed. Otherwise, it will directly affect your simulation. Okay, so whatever, I hope you remember whatever topics we have discussed, right? So how to disable the shadow simulation, right? Then how you can change the floor or background. Okay, how you can disable code sequence trace, how we can increase the size of your view window, and how to close the PLC program window. And after that, finally, reset the simulation and start. Then simulation kernel. Here, go to settings, then go to model options, and then go to simulation. Here we can set How simulation will work? We can set the simulation settings. Mainly, we have two settings: model computation. The second one will be relationship between model time and real data. So go to settings here. Go to settings. Then we have model options. So click model options, right? And then after that, click the simulation. Uh, Display we have discussed, right? Yeah, this floor, everything what I have discussed, right? Yeah, next is the simulation. So here we have two options. One is model computation, and the second one is the relationship between model time and real time. Let's see one by one. So coming to the model computation. So in this model computation, here there is one parameter called simulation increment. So what is the meaning of simulation increment means the simulation update. So for example, if now I have entered 0.04 seconds, right? So this means in 1 second, this will update 25 times. Okay, so this is the meaning of this simulation increment. If you use this type of small value 0.04, you will get more accuracy, but more CPU will use. Your simulation will becomes more realistic. So now it is 0.04. But if you use say 0.5, you will get less update. Your simulation will be very faster, but your smoothness, your robot motion smoothness will be very less, and it will get some wrong behavior also. So as per the first law, they are saying that do not change this value 0.04 default value. And then coming to the relationship model time and real time. Here you can select the simulation speed. We have option one, progress preferably in real time. Okay, this is the default actually. Progress preferably in real time. That means simulation will travel parallel to the real time. That means, for example, if the real robot is taking 10 seconds time, in Ciros also it will take 10 seconds time. So this is more convenient. This is more convenient in CP Factory and Robotino also. And allow this skipping of model visualizations. Okay, if your computer is slow, some screen updates, this will skip. Because of that, your simulation will be correct. Okay, will faster. Otherwise, it will be slow. But the thing is that only visual will reduce. Allow skipping of waiting times. Next is allow skipping of waiting times. If there is no process is happening, Ciros will avoid the unwanted waiting. This also will increase the simulation time. Next is progress faster than real time. If you enable this, Ciros will simulate the scenario very quickly because the progress faster than the real time. For example, if your real factory is taking 10 seconds time to complete, Ciros will complete it within 2 seconds time. This is actually used in high production simulation. Then progress, we have another option called progress slower than real time. That means this will reduce the speed of the simulation. This is for debugging, to understand the PLC program, to see the robot motion step by step. Then timestamp. So timestamp means the model time. In MES4, timestamp is equal to real time. See, we have timestamp. So timestamp in Ciros will be based on model time, but in MES4, it will be based on the real time. For example, in a real scenario, a process is taking 10 seconds to complete. So real-time mode, Ciros will be taking 10 seconds and MES will take also 10 seconds time. So faster than real-time mode, 10 seconds model time, but real time it will take 2 seconds. MES will record 2 seconds. Okay, now we'll see the exercise. You have to change the simulation increment to 0.5. Okay, and check the simulation. After that, you have to check this faster than real time, and also change this to default to 0.04 seconds. So do not change this value actually. This is as per this manual. Do not change this simulation increment value 0.04. Then coming to the data logging. So data logging means during the simulation, whatever informations, whatever data, it will record so that we can see it later. That is what is called data logging. So through this data logging, we can see the different data such as PLC inputs, outputs, variables, sensors, simulation performance, CPU load, update time, etc. Okay, go to settings, right? Go to settings, and after that, go to model options. Then there is an option called logging. Okay, so go to settings, model options. Here, there is an option called logging. Where is the logging? Yeah, this is the logging. Okay, so here from this we can select the parameter we need to log. What parameter you need to log? From here you can select. Okay, after that we can start the recording, and later on we can see this is like a graph. Okay, now this is showing data logging in real time. Okay, here the simulation is in real time mode. So the simulation increment is 40 millisecond, and the computer is very fast. So it will take very less time to update the simulation. So the remaining time, Ciros will wait. And because simulation will not cross the speed of the real time. For example, in simulation update, 1 millisecond. Okay, it will be waiting for 39 milliseconds. So totally 40 millisecond, right? Progress faster than, if you enable progress faster than real time, that means there is no waiting time. The CPU will quickly finish the simulation. And in the simulation, you can see the time usage is more. If you disable shadows, your performance will becomes increase. Also SSO, if you disable SSAO, again it will improve the performance. So for large CP factory models, shadow of SSAO off is required. Then let's go to the next exercise. Okay, open the model, enable the logging, select the faster than real time option, and then run the simulation, see the graph. So how to remove manual working place? Because if manual operator will be there in the simulation, they have to wait. So we cannot test the maximum speed. Okay. Next is how we can connect this Ciros to MES4. Okay. So the first step is to create customer, and then after that we have to add all the resources like robot, magazines plus pick and place warehouses, etc. And every resources having an MES ID, PLC type, PLC IP address. And after that, define the topology and then start the simulation. Okay, so now I have opened this production control, sorry, MES4, right? Okay, so let's see. Yeah, go to production control and there is an option called resources. Okay, so check all the resources. You have to check all the resources is in green color or not. And then after that, start the production parts, create the production parts. I will write here step by step. Okay, so open MES4, create customer, then add resources, and then yeah, these are the resources here right now, right? And every resource is having an IP address, right? Okay, and then define the topology. You check all the resources color is in green color, and then after that create the production parts, and then create work plan, fill warehouse buffer, and then after that start the production order. Okay, first of all, we should understand what is MES. So MES means manufacturing execution system. So MES is used to control the entire factory. So the entire factory is controlling this manufacturing execution system. It will start the production order, check the status of the machine, communicating with PLC, track the robot, store production data, prepare reports, and finally analyze the performance. So the communication will be like this: MES4, then TCP, IP network, then PLC, a machine, robot, Ciros. Everything will be communicated in this MES4. And coming to the terms and definitions. Okay, in a factory, uh, what are objects moving? Okay, what are workpieces moving? We call it as parts. And we have different types of parts. External production parts. External production parts means the parts coming outside from the factory. Then we have another one is called the production parts. So production parts is the parts manufactured inside the factory is what is called a production parts. And boxes is used to carry these parts from one location to another. We have pallets and carrier, right? So carrier means this will be using to transport through the conveyor belt, and pallet is used to place on the top of the carrier to hold the workpiece properly. Then undefined. Undefined means unknown or faulty parts is what is called a undefined part. So these are the parts. These are the different types of parts in a factory. Then coming to groups and utilities. Groups and utilities means if some parts, okay, will be in a particular category. This is what is called a group. That is what is called a group. Okay, for example, red part will be in one group. Green part, metal part, plastic. So if you take plastic part, will be in a group. Almost finished product. So almost final products will be in a group. So that is what is called a group. Then next is called a utilities. So utilities means this is for transportation. This is to transport this workpiece, right? Like a carrier, box, pallet is what is called a utilities. Then coming to customers, orders, order number, and order position. Okay, let's see customers. So in MES4, we have to prepare the customer first. Okay, so suppose here you are going to manufacture a mobile phone, right? Okay, so who is the customer? So you are going to manufacture this for a customer, right? So first we have to create customer, right? So customer means there is an order number, right? Say for example 1001. Okay, so order number 1001. Okay, so product will be say part A. So how many numbers required? Say 20 quantity required, right? So this is the first step. So I will show you. So the first step is to create customer, right? So every order there will be a unique number. Okay, every order there will be a unique number. So for example, order 101, position 1, part A, position 2, part B, position 3, C, position 3, part C, like that. Then next is resources and buffers. Okay, what do you mean by resources? What do you mean by resources and buffer? So in a factory, every machine is a resource. For example, Robotino is a resource. Magazine is a resource. Press station is a resource. Pick by light is a resource. Assembly station is a resource. Warehouse is a resource. Then buffer means temporary storage area. So we have resources and buffer means temporary storage area. So if the machine is busy, part will wait here. Okay, for example, magazine buffer, Robotino buffer, press buffer, warehouse buffer, etc. So in MES4, the Robotino is treated as a mobile resource. See, This robot, is a special kind of mobile resource. Next is our operations and parameters. See, operation. What is operation? Operation means, suppose here you are going to manufacture a mobile phone, right? Okay, we have to follow different steps or in an orderly manner to get this mobile phone, right? So, for example, drilling hole, press part, pick part, place part, camera inspection, assembly, etc. So, all are operations, right? So, what is the difference between a resource versus operation? So, resource means machine. For example, magazine, press station, robot, camera station is what is called a resource. Where operation is the the job performed by that resource or that machine is what is called the operation. So press station is doing press operation, right? Camera station is doing quality inspection, right? So one resource, they can do multiple operations. Next is parameters. So to do this operation, we need parameters, right? For example, pressing, how much will be the force? 150 Newton. What will be the delay time? 2 seconds. Camera threshold, 80%. What will be the speed? 50%. So those are parameters. So to do the operation, we need parameters. Then, yeah. Then for this operation, so every operation, uh, we have a number, operation number called operation number. Okay. So say for example, operation 100 to pick, operation 200 place, operation 300 camera inspection, operation 401 plus etc. Then next is what is called a work plan. Next is called a work plan. So again, now we are going to manufacture a mobile phone, right? Okay. So we have to prepare the work plan. Work plan means, suppose you are going to manufacture this. Okay, which one will be the first operation? After this, which one be the second operation, third operation, like that. And that sequence is what is called a complete work plan. So for example, magazine will release the part, robot will transport, camera will inspect, pressing operation will complete, and finally go to the storage. This is what is a work plan. There are different types of work plan: production work plan, customer work plan, then commissioning work plan, then template work plan, service work plan, etc. Then let's see the MES for process flow. Okay, this will be showing the order of the work plan. Okay, so first starting from release a front cover on stopper 2, then after that assemble PCB, then camera check, feed part to the magazine, then pressing operation. So MES will complete each and every step like this. Then stopper unit, stopper waiting. So carrier will be coming. So this is the carrier. Okay, this is the carrier, and this is the pellet, and this is the workpiece, right? So the carrier is coming through the conveyor belt. Okay, once it will reach us here, this is the stopper. Once the sensor is activated, carrier will stop. Then after that, the next process will start. So carrier is coming, sensor will detect, stopper close, carrier stop, MES will execute the next step. Then sensor detection. So for example, here the sensor is BG1. So this BG1 sensor will detect the carrier, right? There is a metal screw, the grub screw. There is a metal screw on the carrier. So this BG1 will detect that metal screw. Sensor will detect. Sensor will on. PLC input will on. So PLC knows that okay, carrier is reached. Carrier is arrived. Then RFID reading. So on the top of this carrier there is an RFID tag. So the RFID reader will read that tag. Okay. So for example, what is included in that tag? Order number 1402, order position 1. Once it will be read, PLC will understand that uh, which product this carrier is going to manufacture. Then PLC MES communication. So this one, the PLC MES communication. So PLC will ask to MES, okay, what is the next operation of this carrier? So PLC will send 1402 order number and order position. So MES will check this database. Then get OP command. Get OP command. So MES is giving multiple commands. Get OP for carrier. So using the carrier ID, asking next operation. Then next is get OP for on position. Again, using this order number, order position, using order number and order position, asking the next operation. Here using the carrier ID, here using the order number and order position. Then get first OP for RSC. If there is no order, they will ask whether any new job is available, so that the resource can do. Then coming to the so this is order number and order position, right? So here the order number is 1402 and order position 1. So release cover. Step number 2 will be say assemble PCB. Step number 3, camera check. Then 4, press unload. If PLC is asking, MES will identify the next step from the database. Then get OP response. So MES will send a reply message to the PLC. So the response will be generated using 3 things: resource, OP number, parameters. Resource, OP number, and parameters. Resource 3, OP number 401. Say parameter means say force 150, delay 2 seconds, speed 40%. So using this information, from the MES4, PLC will run the machine. Yeah, next is OP start command. So once the PLC will get a response from the MES, before starting the job, it will send a command called OP start. Okay, so that means PLC is communicating with MES4. That means I'm going to start the operation, OP start. So MES4 will update that particular running status. Say for example, this order number is sending order number 1402, order position 1. Then command OP start. So this command is used to communicate that operation has already started. So in the MES4 database, it will change the status to order created, waiting, running, OP start. Then application is started. Application is started means the real machine working is happening, right? For example, camera is capturing the image, vision inspection, press cylinder, robot in can place, drilling, assembly, etc. So this time MES is waiting. MES is in waiting time. Then OP end. OPN means operate once the operation is completed. Okay, so once the operation is completed, PLC will send again a message to the MES4 using this op end. Okay, so the information will be operation number 1402, or position 1, carrier ID 6. That means this the carrier ID number 6 operation has now completed. Then command OP end. So the parameters used to send MES4, that means operation end, the order number, order position, carrier ID, request ID, and error state. 0 means no error, 1 means error was happened. If there is no error, MES4 step complete, statistics update, select the next step. If there will be an error, then it will activate an alarm, order hold, or error log update. Then MES will check the work plan. Okay, so step 1, step 2, step 3 is completed. Okay, then next go to step number 4. Then RFID. We have RFID, right? So MES4 will write new informations on the RFID tag. So for example, order number 1402, order position 1, resource ID 4, OP number 200. That means go to resource number 4. Then coming to the PLC. So what do the PLC have to do in MES4 mode? What is the job of PLC? Okay, so PLC will check whether the carrier is available or not. Okay, so PLC is checking. Okay, carrier is available. Carrier is available. No. Again, carrier is available. No. Carrier is available. No. Now carrier is available. Yes. Now carrier is available. Then read the RFID tag. Okay. Then it will call the get OP command. Okay. So get OP command means, so MES4 will tell the next operation. Okay, so what will be the next operation means, what will be the resource ID? Resource means the station, right? What will be the resource ID? Resource ID. If resource ID is available, no. Okay. Resource ID not available means release carrier end. Resource ID is available, then OP start. Send a command OP start. Okay, machine will do the job, perform operation. And once the operation is completed, then operation end. it will update in the RFID tag, and stopper will go down and release the carrier, and carrier will go to the next station. So what are the data stored on the RFID tag? So the information stored in the RFID tag will be order number, then order position, and then P number, that means part number. Resource ID means ID of the next resource. Once this is completed, what will be the next? Which one will be the next resource? So ID of the next resource, and OP number means number of the next operation. Then coming to the MES4 system architecture. Let's see the complete MES4 system architecture. This is the complete MES4 system architecture. So everything starts with a customer order. Everything starts with a customer order. Okay. So customer order will updated here, the MES4, right? Then to the Microsoft Access database, festo mes.accdb. Or ODBC connection, PLC or Robotino camera prestation or magazine. Then next is the database backup. How we can take the database backup? Okay, all the order, resources, everything. Everything will be stored in a Microsoft Access database, festo mes.accdb. To take the backup, we have two options. One is manual. Okay, so manually means from this file. Okay, we can copy this file into another USB or pen drive, paste it, we will get the backup. And the second one will be using the MES4 software. Okay, open the MES software and go to tools. There is an option called export database. If you click this, you can save your backup file. Tools, go to data, export database. Okay, so that you can save your backup file. So take backup is required because PC crash, hard disk failure, Windows reinstallation, database corruption, we will have all the data. Then coming to the database recovery, how we can restore this backup file. Okay, so close the MES4 first. Again, copy the backup file. Then if you start MES4, you have two options. One is current database, backup database. Okay, you have two options. One is current database, or you can load a template database. So you can select the backup database. Then how you can see this database through Excel? Open the Excel. Using this Excel, we can see order, resources. We can see the order number, resources, right? Then RFID data, work plan, then status. This will be very much useful to prepare the report. And another one is called using Microsoft Access. Using Microsoft Access, we can access the database. There we can see the table order, carrier, customer, resource, okay, operation, etc. So this is commonly used by developers. Then internal database editor. If you log in like an administrator, go to tools, DB viewer. Through this, you can edit the table, order check, resource check, parameter change, etc. Then coming to the interfaces. MES4 is giving two types of communication interfaces. One is cyclic status and another one is called service calls. So cyclic status means PLC will send the status every 1 second. Every second, resources send status updates every second. So resource means this PLC. So PLC will send the update every second. Service calls means PLC or the ERP system will ask data to the MES4, say for example port number 2000. So the difference between these two will be in status update, PLC to MES4 communication is happening, right? So that means PLC is saying, okay, I am okay, or I am busy, or I have error, right? But in service call, PLC is asking to MES4 what will be the next job, whether the job is completed, where is the carrier. So PLC is asking. Then coming to the port configuration, we can change the communication port. So the default port will be 2000. Status port will be 2001. Client number, say for example 32. Options. Next is cyclic status update. So cyclic status update I have already mentioned, right? So status means every 1 second PLC is updating with the MES, right? So every 1 second PLC is sending status to the MES4, right? So what PLC is sending? The resource ID, right? Resource ID means which PLC and the type of the PLC. For example, Siemens. And what is the current state? If there is no status till 5 seconds, then MES4 will treat this PLC as like offline PLC. Next is state byte. So in state byte having more number of bits. So every bit is a status actually. Okay, for example, auto mode, manual mode, busy, reset, error, error 1, error 2, MES mode, etc. Then coming to the service calls, the next one. So service call means the request response communication, right? So PLC is requesting to the MES4. So there is a request. So request response communication is what is called a service calls. Okay, so PLC client is asking to the MES4 requesting. Okay, then this will give a response. Okay, so requesting, then this MES4 will give a response. So for example, PLC is asking, okay, now we have an order, right? So what will be the next operation of this order? Then MES4 will say, go to pressing station or go to camera station. Okay, so this is same as like go get OP start, OP end, etc. Then next is called a communication simulator. Communication simulator, we can see in tools, go to tools, there is an option called communication simulator. So this is actually a debug tool. That means without using PLC, we can test MES4 using this communication simulator. Okay, what is the job of this communication simulator? So PLC is sending a request, right? It will simulate. So this communication simulator will simulate that PLC request. And also this will be checking what response MES4 should give. And also this will be useful to debug the PLC program. And also we can check whether the branch decision is properly working or not. So for example, PLC is asking get OP. So simulator will send the same request to MES4. So MES4 is saying that, okay, press station or camera station. So that means without PLC, we can check everything. Then service call, right? So tools config SQL. This is only for administrator purpose. Okay. Okay. If I'm selecting this, that is not activated. That means this is not for user. This is only for administrator. So the administrator can add, modify, or delete. That is what is config SQL. And next is parts and groups. As I have already mentioned, in MES4, whatever uh, whatever products we are going to make, okay, every workpiece should be treated as a part. Okay, so in the database, we will store this as a part, and every part is having a number. Okay, every part is having a part number, right? So for example, 1211. In this case, you can see every part there is a number. You cannot change it later, and description also will be there. Okay, so for example, this is a front cover or back cover, and then type. So type means you have to include which part. Is it production part, external part, purchased part, etc. Then base palette. Okay, so this part, which palette we can use for this part. Okay, so based on that, MES4 will select the carrier, and we have an image. We can there is an option that we can add the image of that particular part so that the operator can easily identify it. Then next is called a MRP. MRP means material requirements planning. That means, for example, at what time we need to prepare one particular part. So this we can decide using MES4. Then safety stock, right? What do you mean by safety stock? That means buffer, right? So for example, safety stock is equal to 5, right? If the safety stock is less than 5, then immediately production will start. So this will be a safety buffer, safety stock level. Demand planning. Demand planning means if stock will reduce, immediately production will start. And demand planning plan. Production will not start immediately. It will added planned orders list. Then operator will start later. Minimum lot size. Minimum lot size means at a time how many parts we are going to manufacture. Say for example 10 parts. Next is work plan. So every product we have a work plan. Okay, so the process to manufacture the particular product. So we have customer work plan, right? We have customer work plan for customer order, and we have production work plan for internal manufacturing. Okay, next will be other settings. So other settings means we can uh, we can club similar parts into a group. For example, front cover family. In the front cover family, we can include all the, for example, front cover with fuse, front cover with PCB. We can include all these in a group called front cover family. Then default resource. If the carrier is empty, where should go first? To magazine or to storage? MES will decide everything. Then Robotina. Robotina will take the empty carrier and it will move to default resource. This is to avoid deadlock. So deadlock, what do you mean by deadlock? So deadlock means, for example, station A, Robotina is waiting. Station B, station B is waiting station A. Nobody is moving. This is what is called a deadlock. So nobody is moving. So using MES4, we can avoid this default resource. So now I'm stopping here. We will continue the remaining after 1 hour. Thank you.